Good morning, students. Welcome back to digital electronic class. In the previous class we have discussed the tabular method, that is nothing but Quinn MC Kluski method. We have done one problem based on it, and the summary of that problem is when we want to find out the prime implicants, first thing we need to segregate into different groups based upon the index. So first is index 0, index 1, index 2, index 3. If you do have 4 bits, 4 variables, if they gave it like the range are from 0 to 15, then we need to go for till index 3. If you are getting more than that, then you can proceed further index also you can make it. Then second step, what we have done, we have taken the number into the comparison, like index 0 we have compared with index 1 we compare with index 2 we compare with index 3, like that we compare it. When we comparing it, if you want to go for first reduction, we want to get only the difference of bit needs to be 1. That part we have done. Second thing, after getting the first reduction table, we proceed for the second reduction. Inside the second reduction, what we have done, we have seen that when we want to write the second reduction, we just want to get the two comparison of the bit. One is already 1 dash is the second one we want to write down. So that kind of problem we have seen in the previous class. In today's class also we just want to continue the same concept, that is nothing but tabular method. In that they gave one question. So they gave the question like the Boolean function f is equals to summation m 2, 3, 7, 9, 11 and 13 plus summation d of 1, 10 and 15. So they gave these two values. They asked to using the tabular method. So using the tabular method, we need to get the essential prime implicant of this particular function. So here they gave mean term as well as they gave d. What is d is all about? D is nothing but the don't care condition. So they gave these two values. We need to write its particular table that we need to find out. So how do we find? We know that to write that thing, what we'll do, we'll try to write its table. So first thing would be what actually? First column is all about the index values. So we'll write index first thing. We make the first column. In the first column what we are writing? We are writing the index. First would be index 0. Then second would be index 1. Next is index 2. Next is index 3. So first what we'll write in index 0, after that we'll write decimal number. So since they gave decimal numbers in the question, so we are writing decimal number. Then it's binary combination for mean term and don't care. So binary combination for mean term. So this we are just want to write down. So here what extra they gave in the question, they gave don't care also. Don't care is also considered as mean term only in tabular method. So these bits also we have to consider while we are simplifying, why we want to find out the problem based upon the tabular method. So in that what I am doing, I am using these bits as well as these bits. So this also considered as what? This also considered as mean term. So here make a note of it. Here don't care. So don't care bit is also considered as mean term. So that point you need to keep in your mind. That is very important point that we are saying. So don't care they gave you, but in KMA what we have done, for don't care we put a cross mark. But here don't care bits also you need to consider while you want to write the tabular method. So now we are just want to write, first you see 2. So 2 means what is the binary combination of 2? It's nothing but, what is the 2 I can write? So 2 I do have 0, 0, 1, 0. This is nothing but decimal value. So this I'll write here 2 first, I'll segregate that one. I can write it here 2. So 2 is nothing but 0, 0, 1, 0. That 2 is done. Next I do have 3. So 3 is nothing but 0, 0, 1, 1. That come under index 2. So 3 they gave. So what is 3 value we do have? 0, 0, 1 and 1. Since do we have index 0 in the question? Do we are finding any 0 in this? No, since we don't have 0. So why we'll start with 0? We'll directly start with index 1. So this value I'm writing, I'm starting for index 1. So I'll erase that one, I'll write down this thing. So I'll start from here. I'll take this as index 0. So this is my index 0. So I'll write down that particular thing. Instead of 0, I'm starting from index 1. This is my index 2. Clear? So I do have first index 1 value. What is index 1 decimal value? 2. So what is 2 combination? 0, 0, 1 and 0. That 2 is over. Next is 3. 3 is come under the index 2. So 3 I am writing here. So 3 is nothing but 0, 0, 1, 1. So 3 is done. 2, 3. Now you can take 1 also. What is 1? 1 is nothing but 0, 0, 0, 1. So that I can write here. So instead of 2 I can start from 1 here. So 1 is nothing but 0, 0, 0, 1. I do have 2. So 2 I am writing 0, 0, 1, 0. So 1, 2, 3 is over. Next. 1, 2, 3 is done. Next is, do we had 4? No. 5? No. 6 is there? No. Directly we do have 7. So 7 will come under index 3. So this is your index 3. So index 3, what is the value they gave you? 7. 7 is nothing but 0, 1, 1 and 1. That is 7. After that 9. So what is 9? 9 come under index 2, because 9 is nothing but 8 plus 1, make it as 9. We wrote 9. After 9, 10. 10 is also come under index 2. So 10 I can write here. What is 10 value? 8 plus 2, make it as 10. After that 10, what is the next number? 11. So 11 I can go for index 3. 11 is nothing but 8 plus 2 plus 1 is nothing but 11. So 11 is completed. Now after the 11, next would be 13. So 13 is also come under index 3. So in that what I am writing, I just want to write down this thing. I can continue with this index 3. So tell me what is the next value we do have? We do have is 13. So in 13 what I am writing? 8 plus 2 plus 1. 8 plus 2 is 10, 10 plus 1, 11. Now we want to write 13. So how will write 13? 8 plus 4. So 8 plus 4 is 12. 12 plus 1 is 13. So we got 13. Next, we just want to write 15. So 15 under come under the index 3. So now this is our index 4. So in index 4, what is the number we left out? 15 is left out. So 1, 1, 1 and 1. So as you can see, so we got all those numbers. We wrote all the index values. So what we have done? We want index 1, index 2, 3 and 4. All the values has been covered. So 1, 2, 1 is there, 2 is there. That is, since it consists of only single ones. So we wrote 1 and 2. After that, what is next out? 3. So any other number? No. So 3 is there. 0, 0, 1, 1 is 3. Like that, 3 is over. Next, 7 and 9. So 7 is 3. We put it, it's 3 coming in that particular thing. We do have is 3. So we put it. 9 is over. Next, after 9, 10 and 11. So we have taken 10. We have taken 11. After that, 13. So 13 is come under the same thing. 8 plus 4. 8 plus 4 is 12. 12 plus 1 is 13. Then 15. So 15 is nothing but all ones. So now we got it. Next thing is that we need to write again what? Decimal. So we are just want to compare it. So in that what we will write first next column? Decimal number. Then its binary combination. So now compare it. What is the next step? After writing this into index value, next thing is that comparison between first index value into next index value. So what is the first index? 1. Here, next index is 3. So try to compare 1 with 3. I can compare it? Yes, I can. Because 0, 0, 1, 1 here, 0, 0, 0, 1. So only the single bit is, this bit is differ in both. So what is the first decimal number? 1, 3. In 1, 3, 0, 0, dash 1. I have compared 1 with 3. Now try 1 with 9. So here, can I compare 1 with 9? Yes, I can. 1 with 3 is over. Now I am doing 1 with 9. So because 0 here is 1. Remaining 0, 0 and 1 is as it is. So what I can write? I can compare with 1 with 9. So what I am getting if I am comparing 1 with 9? So it's what? Dash 0, 0 is same. 0, 0 is same. 1 and 1 is same. So 0, 0, 1. That we kept it. So that is as it is. Now comparison between 1 with 3, 1 with 9 is over. Now try 1 with 10. Can I do it? No. All bits are different. So 1 is done. Next try 2 with 3. So 2, 0, 0, 0, 1, 1 and dash. I can put it. So I can compare 2 with 3. So what I am getting? 0, 0, 1 and dash. 2 with 3 is done. Now try 2 with 9. So can I do with 2 with 9? No. One bit is different. One more bit is different. That means comparison of 2 with 9 is not possible. Now 2 with 10 you try. So 2 with 10, see this bit. Yes, I can do it. First bits are different. So I can go with 2 with 10. So what I'm getting to do with 10? Here 0, here 1. This bit will only differ. Remaining bits are same. 0, 1, 0, 0, 1, 0. So what I'm doing? 0, 1, 0 with 1 dash. The first index comparison is done. What I'm getting? This is nothing but first reduction. So we're done with first reduction of index 1 with index 2. Next what I'm doing? I'm comparing now second index with third. So what I can do it? See here 0. I can compare, yes, one bit is differ, remaining is same. So now what I'm doing? 3 with 7 I'm doing. So I can get 3 with 7, 0, dash, 1 and 1. That 3 with 7 is done. Next 3 with 11. Try with 3 with 11. Yes, 3 with 11 with possible dash, 0, 1, 1. So dash, 0, 1, 1. What I'm doing? 3 with 11. So 3 with 11 is also done. Next 3 with 13, can I do it? No, because all bits are differ. 3 with 3 is not done, not possible to do it. Now try 9 with 7, 9, no, not possible because only one bit is same, remaining all are differ. 9 with 11, 1, 0, dash 1. So 1, 0, dash 1. To whom which one I'm doing? 9 with 11. So 9, 11. Next 9, 13. So 1, dash 0, 1. So 1, dash 0, 1. Which number I'm doing? 9, 11. 9, 13. So this is for 13, right? So 9, 13 is done. Next 10 you try with 7. Possible? No. 10 try with 11. Yes. 1, 0, 1, dash. 1, 0, 1. 10 with 11. So 1, 0, 1, dash. So this which bit we are doing? 10 with 11. 10, 11. We're done. Next 10, 13. 1, 2 bits are differ, so we'll not take it. So that means the next comparison is also completed. Next what is left out? Index 3 with index 4. All is possible because 3 ones, here is also 3 ones. So what I'll get if I'll compare it? 7, 15. Next will be 11, 15. Next would be 13, 15. If I am comparing 7, 15, dash 1, 1, 1. Wherever 0 is there, put the dash. So here what I can write? 1, dash, 1 and 1. Next here 1, 1, dash and 1. So I have completed my first reduction. Next thing what I need to do it? I need to write the next reduction. That means I am writing decimal number and I am going for second reduction. Now we need to go for dash wise. Till now what you have done, students? So we have done first reduction of two comparison of index 1 with index 2. Clear? So you cannot compare 1 and 2. It's come under same index. That value cannot be compared. The one which are differed, like index 1 and index 2. Each bit you need to compare. 1 with 3, 1 with 9, 1 with 10. Try to see whether the comparison is there. Is it possible or not? If it's possible, then write it down. If it's not possible, leave it. So I have done like this. I have done index 1 with index 2, index 2 with index 3, index 3 with index 4. So I got these all my first reduction. After that, what is the next thing? We need to go for second reduction. In that same thing, this group comparison with next group, that group comparison with next consecutive group. Now see, 1, 3 having the dash on second position. Do we have like this anywhere? You here. So 1, 0, dash 1. So this I can compare with this, right? 1 is there, it's 1. So first thing what I'll write 1. Dash is there, yes, here is also dash. I'll put a dash. Next what do I have? 0 and 0. I'll put a 0 and I'll put the dash. So what I'm doing? 1, 3, then 9, 11. So this is done. This comparison is over because dash is matching in both. So we just see the remaining bits. Bits also matching. So these two bits are matching. We got, since second reduction, we got 2 dashes. Now see 1, 9. Here is dash is there. Here is also dash is there. 0, 1, 0. No, not possible because here 2 zeros, here 0 and 1. Yes, I can do it, right? Because only one is differ. So what I can write? 1, 9. Next is, after 1, 9, what is the next value? In the first dash, 3, 11. So this I'm taking 1, 9, 3 and 11. So in that what I am doing, I am having the dash here, I am having the dash, that I am keeping as it is. 0 is also as it is. 0 here, 0 here, 0 here, here 1. So I can put the dash there, and 1 here, and here is also what is there, 1. So I can put it 1. So what comparison is done? 1, 9, this is there with 3, 11. 3, 11. So what is that? Dash is there, that we put it. 0 is there, that is also kept it. 0 and here is 1. That's the reason we put the dash, and that 1 is completed. Next one, last dash. Do we have any last dash? Yes. So 1, 0, 1. So I can compare this with, where is the last dash? This one. So what is this one bit value? 2, 3, 10, 11. So tell me what we'll get. Here 1, here is 0. So means dash. 0, 1, 0, 1 and again dash. So what we have done, students? So we compare 2, 3 with 10, 11. So here 1 is there, here 0 is there. That's the reason dashes came there, because bits are differ. Bits are not same. 0, 1 is here, 0, 1 is here, and dash is also there. That we have done. Now try 2, 10. Here I can do it. 2, 10, 3, 11. So do we have 2, 10, 3, 11? Means this is same. This is also same. 2, 10, 3, 11. The same bit it is comparing. That means this all are completed. Now go for next. This one with next one. You just check it out. Here dash is there. Do we have dash in this? Yes. I can compare 3, 7 with 11, 15. So 3, 7, 11, 15. So I'm just doing it. 3, 7, 11, 15. So 3, 7, 11, 15. So what is the bit value we do have? Here, there, 0, here is 1. So I can put dash, dash, 1 and 1. That is over. Next, try to compare. This already is done, comparison. If you want to check it out, you can go for it. So dash is there. Do we have dash? Yes. 3, 11, 7, 15. This also commanded the same. So 3, 11, 7, 15. So 3, 11, 7, 15. That means the same bit. Now check for next. Second dash. Yes, here second is there. So what I can write? 1 dash dash 1. So 1 dash dash 1. What bit I am comparing? 9, 13 I am comparing with 11, 15. So 9, 13, 11, 15. So what I am getting? 9, 13. 1 is there. Yes, here 1. Dash is there. Yes, 0 and 1. That means is also one more dash. Then 1 and 1. That is as it is. So this all are compared. Only what is left out? This. Do we had third dash anywhere in this? Yes, here is there. Here is also there. So 1, 0, 1 dash. The same dash is there, 1 is there. That means 9, 11, 13, 15. That is also comparable. That means all are compared. That is done. Now try to check what is the common in all. Like this, I can see 1, 9, 3, 11. It's repeating 1, 9, 3, 11. That means both are same. Any one you should take. That is the first thing. Second, in this, you see 3, 7, 11, 15, 9, 13, 11, 15. Both are differ. It's not same. So what I can write for this? This are separated. This is your A. Now we have to write the letters. This is your B. So this is your C and D. So we found A, B and C, D. So what we have done, students? So see, from starting we found all index value. We compare it, each consecutive index value. After comparison we wrote decimal values for all. After that we went for first reduction by comparing this with the next one. We got the answer for it. After that, first reduction of that particular group 1 we compare with group 2. Then group 2 we compare with group 3. Like that we did it. We got this particular second reduction. That means we found prime implicant. What is left out now? We need to go for essential prime implicant chart. That is table. After finding that one, we can got the answer directly. So let's see. Before doing it, just I'll pause this video for 2 to 3 minutes so that you can note it down, this particular thing. It's very important. Definitely it will 10 marks question is sure for you. Just copy this particular part. Then I'll move towards the essential prime implicant for that. So students, so we are finding the essential prime implicant table for it. So what is the first criteria for doing this thing? We'll try to make the chart. That is nothing but the table for essential prime implicants. So we just want to write down those values, essential prime implicants for it. What is the first thing? We'll write the, what we'll write? We'll write the prime implicants value. We'll make it, what is the first column? It's about prime implicant. We do have A, B, C and D. So these are our prime implicant values. So we just want to write down those values. In that A, B, C, D are called as prime implicants. So we wrote prime implicants. In that, what are the values it's coming? 1, 2, 3. So 1, 2, 3. We'll write that particular 1, 2, 3. After 1, 2, 3, next is 7. 7, 9. 7, 9. Then 10 is there. 11 is there. 10, 11. 1, 2, 3, 7, 9, 10, 11. And 15. So we do have these all, right? We wrote it. Next, what is A means? A values are what actually? 1, 3, 9, 11. So at 1 is put across 1, 3, 9 and 11. We put the cross. Similarly for B, what is B value? 2, 3, 10, 11. So 2, 3, 10 and 11. So this we wrote it. That we put this thing. We put this thing 9. Next thing C. What is C value? 3, 7, 11, 15. 3, 7, 11 and 15. We wrote it. Next is D. What is D? 9, 13, 11, 15. 9. This is our 9. 13, 9, 13. So we just want to write 13 also, one more. 9, 13, 11 and 15. So this is 11, this is your 15. So now see which is single. Column wise you just check it out, which is your single one, that you need to take it down. So since 1 is coming in A, so put the circle over there. That is nothing but A is your essential prime implicant. Next, second column, 2 is coming once. B is also essential prime implicant. We'll put the asterisk. Likewise, we had 7. 7 is there in C. C is also essential prime implicant. Likewise, any other thing, this is twice, this is coming once. That means 13. 13 means D is also essential prime implicant. So column wise we'll see 13 coming once, 10 is also coming once, here is there. Then 9 coming twice, will not take it. 3 is coming thrice, will not take it. So 1 is coming once, 2 is coming once, 7 is also coming once time, 10 is also coming once time. So like that 13 is also come under once only. So now we got all these things. So these A, B, C, D all are essential prime implicants. Now we need to write the function for it. So how do we write the function? F is equals to, so if I want to write here, I'll mention this thing because I do have the value here A, B, C, D, I can go for it. F is equals to, tell me what is A? This dash 0, 1 dash. That means if I'm taking W, X, Y, Z for it, this is nothing but X bar and Z. First answer is X bar and Z from A, essential prime implicant. Similarly, B, W, X, Y, Z. So X bar and Y. So I can write for it X bar and Y from B. I can go for C. It's nothing but Y and Z. This is for C. Now for D. D is nothing but W and Z. W and Z. So this is the actual function of our essential prime implicant function. So now we got total answer by getting the prime implicant table and by getting the essential prime implicant table. In essential prime implicant table, what we have done? We got A, B, C, D's, right? Here we do have A, B, C, D, all values. In that what we have done? We have seen order wise all the mean terms. So in that what we had? We do have A, 1. So we put it 1 over there. We do have 2. Do we have 2? Yes, 2 is there. We put the 2 next. We do have 3. So we put the 3 there. Then after that we do have 7. So we have kept the mean term 7. Next is 9 is there. So here 9 so many times. So 9 we kept it. Next is 10. So we do have 10. We kept the 10 there. We do have 11. So we kept the 11. Next is 13 is come under this. 13, 15. We wrote all the terms. After writing the terms, what is the next criteria of us? We just want to find out the values for it. So how do we find the values for it? by comparing it, by putting the cross. So by putting the cross, what we have done? We have seen for A, what are the numbers? For A, what are the numbers? 1, 3, 9, 11. So we do have 1, 3, 9 and 11. So all that we put the crosses. 1, 3, 9, 11. That is done. After that, next is for B. For B, since it's are repeating. For B, this is ones. So what we have taken? 2, 3, 10, 11. So for B, 2, 3, 10 and 11. We put again crosses. Next is to just want to write the C. For C, what we'll do it? For C, we do have 3, 7, 11, 15. For C, 3, 7, 11 and 15. We put the crosses. After writing the C, next would be D. For D, what is the value? 9, 13, 11, 15. So for D, 9, 13, 11 and 15. We wrote all the values. What is the next criteria? We just want to check the mean term which is coming once. Should not come twice. For that, what we have seen column wise. One is coming only single times. This is not repeated much further. For that, what we have taken? One is put a cross and with circle. Likewise, 2 is coming once. That's the reason we put the circle. After that, we just want to go for C. 3 is coming here, 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 thrice. That means we don't want to write it down. We just want to don't put the circle because it's coming repeated. Like that, 7 is coming once. So we put the circle and cross. Next 9 is coming twice. So we are not taking. 10 is coming once. So we put the circle. Next is 11 is coming in all the numbers. Next is 13 is coming once. So we put a circle. 15 coming twice. So we will not put it. That means the term, the one which is coming circle, in which prime implicant it is there. It is there in D. The D is also essential. How do we assign it is essential? By putting the asterisk. You need to put the asterisk. That means D is there. Likewise, this term is come under C. So we put for C. C is also there. Then we went for B. B is having twice. Then having A. So that means all our A, B, C, D are essential prime implicant. So that's the reason for A, B, C, D, we just want to write down the function. So for A, what are those value? Suppose I am assuming this is W, X, Y, Z. So dash means we will not write that one. We will not write because we don't know whether it is 0 or whether it is 1. Like don't care. How we have done in K-map, don't care. Likewise, we don't know about that value. So we are not writing it. So we are writing for X. X is 0. That means it is X bar. Z is 1. That means it is Z. So we wrote for A. Twice it is there. So we wrote once that particular A essential prime implicant mean term. Similarly, we went for next one. What is the next one? This one is the next. X is there, X is 0 and Y is there. Remaining are dashes, that value will not take it. So we got, this is your X bar, this is your Y. So we wrote it X bar and Y from B essential prime implicant. Likewise, we do have C. In C, Y is there once, Z is there 1. That means it is Y into Z. Plus for D, we do have W and we do have Z. So we wrote it W and Z. So we found actual our function f is equals to this whole thing. So we got the complete function now by comparing the table from essential prime implicants, and we found the values and we wrote the functions. So this is the way you have to write complete steps and the essential prime implicant chart, then lastly your answer. If you have done every steps properly, then you will get the answer and you will get the 10 marks. For sure, you will get this question in your main external exam paper. So I'll give more questions for you to practice at home. Try it. If you are getting any query, send me the mail. I'll give the mail ID in the description box. Try these all questions. If at all you are not getting it, you can message me. I'll give my number as well. So thank you for today's class. We will see more problems. These kind of one more problem we'll do it. Some different numbers, numericals we'll take it, and the mean terms will take different, and we'll try to solve the tabular method. Then we'll move to the next unit. You just check this complete content. So students, we just want to give one question for you to write, practice it. The question is f is equals to summation m of 0, 1, 3, 5, 7, 11, 14 and 15. This is the question by using Quinn MC Klasky method and hence obtain essential prime implicant. So this is our question, students. They gave the mean term 0, 1, 3, 5, 7, 11, 14 and 15. In that they asked to go for tabular method and find out the essential prime implicant by considering these all. So the same thing, by using this tabular method, you need to solve. You have to first write down the binary combination, then index 0, index 1, index 2, index 3, whatever, index 4 if it's coming, then comparison. After comparing it, you will get the prime implicants. Then you need to put a chart, that is nothing but like essential prime implicant table, then you will get the answer. So try this question and practice it. If you won't get it, just ask about your query. In the next class, I will just go for one more problem based on the same concept. Thank you. Thank you very much.